Next, we have Vincent St-Amour, who's going to be talking about his how he writes his slideshow programs.
Nope. Let's just confuse you. Can you see that?
It's cut off on the left.
It's cut off on the left. Let's move it a bit.
That's better.
Is it better? Wait, no, that's not better at all.
It's snapped to the...
Modern. It's full screen?
Make it not full screen.
Yeah, how does that work?
Just drag it off the top. There, like that.
That's better. Alright, so today I'm going to be talking about one of the new additions to Dr. Racket's tool roster, Optimization Coach. So in a nutshell, Optimization Coach is a tool that helps you make your programs faster. How does it do that? Well, I'll show you with an example. So here we have a simple illustration of Cantor pairing. Cantor pairing is basically just a way to take two numbers, in this case the x and the y coordinate, and encode that as a single integer. So you go from two integers to one. And the way it goes is you follow this pattern, and so to encode the number 4, you take the fourth point, and it's going to be 1, 1, coordinate 1, 1. You don't need to understand the math of it, this is just a running example. So here we have a tight racket implementation of Cantor pairing. And it's not very, very fast. Let's run it and see. Yeah, well, we're just getting. Was that? What was that? All right, 3.3 seconds. All right, now let's have a look at the code and see what's going on. So we have the unpair function, which takes one integer and splits it back into the two. So it takes the coordinate on the line and gives you x and y coordinates. And you have the and before that you have the pair function, which takes the x and the y coordinate and gives you the number on the line. So, as I said, you don't need to fully understand the math. As for the types, Sam's going to be talking about type rack later. Now we're interested mostly in the speed of it. So as we see, it's not as fast as we would like. So let's launch Optimization Coach. And Optimization Coach is going to show us things that are right and things that are wrong performance-wise about our program. So for now, it has a lot of things to say. So we can have a look at what it says. Let's, for instance, have a look at the check function. We're going to show optimization info. It's pretty small. Hope you can read it. If not, I'll read it aloud. So Optimization Coach tells us that the check function was not inlined in its uses, and that may be a source of slowness, because inlining opens up more optimizations. So Optimization Coach is reporting to you what the compiler is doing. So the compiler is no longer just doing things behind your back without knowledge. The compiler tells you what it's doing, and so you can keep an eye on it and see if it's doing what you think it should be doing to make your program fast. So we're not going to be talking very much about inlining today. It's still experimental support, so let's move it out of the way. And let's concentrate on other optimizations, the ones that are performed by the Tight Racket Optimizer, which does type-driven rewritings. So let's have a look at what Optimization Coach has to say about that expression there. If you can read, Optimization Coach has two things to say. First of all, the whole expression in red has a type that's real. But the optimizer could make your program faster if this was the type float. Okay, we're talking about integer coordinates here, so using float sounds a bit unnatural. So we're going to not worry about that for now. But the second recommendation sounds a lot more interesting. It's telling us that a square root function could potentially return a complex number, because if you take the square root of a negative number, you get a complex number. And that's preventing a lot of interesting optimization from happening. And Optimization Coach tells us right here, I could do, the Tight Racket compiler could do better in terms of optimization if you were to replace square root with FL square root. So let's give it a try and see what happens. So let's see the time. So we're gonna wire Racket Flonum, use FL square root. All right, let's see. Oh, We have a type error. We need to fix that. Is that working now? I think it should. Yes. So now let's run it and see if it's any faster. So remember, the time to beat is about 3 seconds, 0.3. Oh, that's already a lot faster. So, did you see what happened? You had a program. Optimization Coach told you what the compiler was doing. It also was telling you what it was not doing, and it told you exactly how to fix it to make more optimization happen. We did that, now it's faster. All right, now we can try the other recommendation it gave us to see whether using floats instead of integers would make things faster. Let's give that a try. So let's replace integer with float. Not that one too. I said that one, yes. All right. Now these are not exact integers anymore, so let's just get rid of that. Oops. No need for the assert. All right. Is it type checking now? Nope. Yes, because we can't turn something that's already a float into a float. Makes sense, right? Expected integer. Why is it expecting an integer now? In times. Oh yeah, we're using quotient here. But so yeah, the one thing that optimization coach doesn't tell you is what exactly you're going to need to change if you want to change the types. But the type system tells you that, right? Now finally we need to change that into a float. Now that should work. So we are at 2.3, 1.8. So it's even faster now. But now we're using floats for something that really should be integer computation, right? We're talking about points on a grid. So floats feel a bit unnatural. But that's the beauty of Optimization Coach. It just told you what you could be doing. If it turns out that you're okay with using floats, which you may be, because we're still dealing with pretty small numbers, then you can use floats if you want. But you, the programmer, remain in the driver's seat. And that's what's important with optimization coaching. It gives you recommendations, but you're free to refuse or to accept and get faster programs. All right, so just to wrap up, a couple of words about what you can do with it. So Optimization Coach ships in Racket. It has for a couple of for a few versions. Currently, it supports type racket optimizations for obviously type racket programs, and it supports experimental support for inlining optimizations for any racket program you want. You can either click the button on the top right if you're in type racket, use the view menu, view show optimization coach in another language, and it's going to get there. There's more goodies coming in the pipeline. I'll be happy to talk to you about offline if you're interested in that. So that's all I have for you today. So, do you have any questions?